Hey guys, today's video is about frequent item set mining. To recap, there are two steps to generate strong association rules. We've talked about how to find all the frequent item sets in the last video, so we'll discuss how to generate strong association rules now. To begin with, the rules are based on frequent item sets, which we found in step 1. Frequent item sets are actually the foundation for strong association rules. By deriving the rules from frequent item sets, we can save the effort in checking the support is larger than minimum support threshold or not. Therefore, we only need to check whether the confidence is larger than minimum confidence threshold, and confidence is the support of the union of A and B divided by the support of A. There are 3 steps to generate strong association rules from frequent item set. First, we generate all non-empty subsets for each frequent item set K. For example, if a frequent item set contains 2 items B and C, then the subsets are B alone and C alone. The second step is that for each subset S, we calculate the confidence of rule S to K minus S. K and S are 2 item sets, and K minus S is an item set that contains all the items in K but not in S. One thing might be confusing is that the right-hand side is K minus S, not K. It's because we interpret the confidence like the left-hand side implies right-hand side. It's meaningless for an item to imply itself, so we remove the item from the right-hand side. Further, the confidence of this rule is essentially the support count of K divided by the support count of S, because K is the union of S and K minus S. The last step is to simply check whether the confidence in step 2 is larger than minimum confidence threshold. If this condition is satisfied, the algorithm will output the rule because it's a strong association rule. Let's look at an example. We found all the frequent item sets from a priori algorithm from the last video. We ignore the item sets that only contain one item because they don't have any non-empty subset and we cannot generate association rules from them. Therefore, there are only 2 candidate item sets left, and we start with the item set containing A and B. Suppose the minimum confidence threshold is 0.2. We first find all the non-empty subsets of this item set, which are A alone and B alone. Just to remind you, the rule we are going to generate is S to K minus S. In this case, K is the union of A and B, and S is A alone or B alone. Second, we calculate the confidence for the 2 rules we generate, since we have 2 possible S. The confidence of the association rule is actually the support count of K divided by the support count of S. So the confidence for the rule A to B is 1. For the rule B to A is 2/3. Both of the rules are strong because their confidence is larger than minimum confidence threshold. In fact, the association rules must be derived from a subset of frequent item sets. Otherwise, the support of the rule won't be larger than minimum support threshold. Consequently, the rules cannot be strong. Alright, let's look at another candidate, the union of B and E. The non-empty subsets are B alone and E alone. Once again, K is the union of B and E. S is B alone or E alone. Then, we have 2 candidate rules, B to E and E to B. These 2 rules have confidence 2/3 because there are 2 transactions containing both B and E, and there are 3 transactions containing B or E. Thus, the rules are considered strong because 2/3 is larger than 0.2. Just to recap what we did in this example, we have 4 transactions in a database, and we use a priori algorithm to find all the frequent item sets. Then we try to derive the association rules based on the frequent item sets. However, we ignore the item sets that only have one item because it makes no sense to create a rule like A to A. Then, we deal with one candidate item set at a time. We generate all potential association rules as 2k minus s. Further, we check whether the confidence of these rules is larger than minimum confidence threshold. If this condition is satisfied, we output the rule. In the end, we generate 4 strong association rules, and its results might be applied in marketing strategy. This whole operation can be done in few command lines in Python, but understanding the logic behind it will help you set the parameters more reasonably. Anyway, that's how we generate the strong association rules from frequent item sets. Thank you for watching my video and see you soon.